Hello again. So one of the inconveniences in the design I described in my last video is that you can overpressure the balloon to the point it goes bang or flying off around the room. So a way of preventing that is to have what's called an overpressure relief valve. So what I've done is taken the same sort of setup we've got at the moment for the balloon. So there's a equal T and a stem elbow on which we've got the balloon mounted, and I've done exactly the same thing here, again, except on this stem elbow we're going to mount the escape valve. I've been trying to figure out how to make a simple one of these for several days, and what I've found is one of these stop ends made by a company called Plumshaw, which they had in B&Q. That's where I got this one. But the good thing about this stop end is that it unscrews, and what you're left with, you've got this push fit part, which you don't need, a compression ring, which you also don't need, but the bits you do need are this cap and an O-ring. And so the cap, if you look carefully inside there, has a little pocket which fits perfectly over the top of the 15mm stem, with a little gap all the way around so that the air could get out. And the O-ring, when you fit it over the stem, and this rides up and down, and then the top of the O-ring seals around that edge inside. So if you can use an elastic band then around this, so that when the pressure gets over a certain value, this lifts off the stem, opens the valve effectively, and lets the pressure out. So I'll show you how that works now. So I'll take the O-ring, fit it over the stem like so, take the cap, fit that over the stem. Now I've got a set of 5 different sized elastic bands, and the one that seems to work reasonably well with this is the blue one, which is the second smallest out of the 5. So if we take one of those, what I'm going to do is just hook it over the top of this cap and underneath the bottom of the stem elbow. Do that. Right, this will probably leak a bit when we first start it up, and then we have to adjust it a little bit until it settles at the pressure that we want. So that we know exactly what that pressure is, I've made a manometer, which is essentially a U-shaped piece of tubing. See that there? Which I've filled halfway up with coffee so that it shows up on video. And when you apply pressure to this side to which the pressure is applied drops, whilst the other side raises. And the difference in the height between those two sides is the pressure in centimetres of water. So I'll show you what happens. Okay, that'll do. Right, I'll close this valve all the way to start with. Open the gate valve to let the air in. Now I'll start opening this so that the balloon fills up slowly. Feel for any air rushing out around there. There is a little bit, so turn that up a bit. If you rotate it around a bit, that often sits the O-ring a little better. He says, famous last words. Right, there we go. That seems to be fairly happy. Alright, so that balloon's inflating now. You can see the open leg of the manometer's rising. We'll go and measure what pressure we've got. So that's at about 21 centimetres of water at the moment. A good pressure for ventilation apparently is around 30 centimetres of water. So we'll leave this going and see what pressure it settles at. 25. So now that's at 33 centimetres there. Let's have a feel around this valve. Let's see again. Yeah, that's not too bad. What's that sort of that? That's about 26, 27 centimetres, which is not too bad. Really, what you could do with on this setup, if you mounted everything down to a piece of board, a bit of wood, plywood or something, you could have a pair of screws and put the elastic band across the pair of screws, and then by adjusting the height of the screws, or one of the screws, you could change the amount of elastic, the amount of force that's generated by the elastic band back down on the cap, and thereby use that to control the pressure that the valve kicks in. Whereas at the moment I'm having to unseat the O-ring in order to do that, which then means you have to fiddle with it a little bit to get it sealed again. But in principle, it's not too difficult to adjust, and you can see that's now settled at pressure, and that's settled out. Yeah, 27 centimetres, which, as I say, is a decent pressure for ventilation. So thanks everyone again, and yeah, good luck with your own experiments, and hopefully we can develop this a little bit further. Thanks very much.